This is Pre-Calculus A, Unit 4, Polynomial and Rational Functions, Lesson 6, the Operations with Rational Expressions. Okay, so basically what we're going to do is we're going to add, subtract, multiply, and divide rational expressions. Rational is just a word meaning can be expressed as a fraction. Rational means fraction, basically. Okay. And so for this purpose, we need to review a little bit how to add, subtract, multiply, and divide fractions, because we apply the same concept to rational polynomial expressions. Okay, so let's review a little bit. Let's say we have 1/4 plus 2/3. I'm going to use a simplified version here. I'm going to multiply the left-hand equation by 3 on top and bottom, and the right-hand equation by 4 on top and bottom. You recall the idea of getting a common denominator. It hinges on the idea that I can multiply top and bottom, numerator and denominator of a fraction by the same quantity. In essence, I'm multiplying by 3 over 3, which is 1, and to multiply by 1 doesn't change the value of the number. Same thing with 4 over 4. Multiplying by 4 over 4 is 4 over 4 is 1, and multiplying by 1 leaves it the same value. So it just is a different expression, or it creates an equivalent fraction. Okay? And then we end up with 3 times 4 for 12 on the denominator, 3 times 1 on the numerator, 2 times 4, 8 on the denominator, on the numerator. 3 plus 8 is 11 twelfths. Okay? So another way to think of this is crisscross across. There's kind of a pattern to it. My students used to call it crisscross applesauce, right? Multiply the diagonals. 3 times 1 is 3. 4 times 2 is 8. Add 3 plus 8 to get 11, and multiply 3 and 4 to get 12. Okay? So you can do the same thing for subtraction. Subtraction is the same idea. So let's say we have 4/5 minus 1/3. Crisscross applesauce. I'm going to use crisscross applesauce. So 3 times 4 is 12. 5 times 1 is 5. 5 times 3 is 15. 12 minus 5 is 7/15. Okay, so it all comes down to getting a common denominator. Okay, so to multiply fractions is a cross. So add, subtract, multiply. Let's say we have 2/3 times 3/8. Okay, we can multiply straight across, just straight across. 2 times 3 is 6. 3 times 8 is 24. And then we can reduce by dividing top and bottom by 6, right? And 6 times 6, or 6 divided by 6 is 1. 24 divided by 6 is 4. Now we do know that we could have simplified this problem a little bit differently by doing it this way. 2/3, 3/8, but 8 is 2 times 2 times 2. And we could do some canceling. 2 divided by 2 is 1. 3 divided by 3 is 1. And all that's left is 1 on the numerator, because everything canceled out, and 4. This concept of factoring and canceling is going to come into play, right? So we can factor and cancel common factors on top and bottom. Note, though, that you cannot cancel 0 over 0. So do check for zeros. Now, obviously, no zeros in the factors of these numbers, but there can be zeros in the factors of polynomial expressions. Okay? Division is a matter of keep the first and flip the second. Or yours is not to reason why, but to invert and multiply. In other words, if I do 2/3 divided by 3/8, that is the same as 2/3 times 3/8. Or written a little differently, 2/3 divided by 3/8 is equal to 2/3 times 8/3. And 2/3 times 8/3. I forgot to flip on the first one here. My bad. Well, 8/3. Okay, be familiar with it in both cases. In the complex fraction a fraction of fractions or dividing fractions. Okay, and again, 2 times 8, multiply straight across is 16. 3 times 3 is 9. You get 16/9 in both cases. Leaving them as an improper fraction, or you can do it as a mixed number, 1 and 7/9. Okay, so that's a little bit of review of how to add, subtract, multiply, and divide fractions. Now let's apply it to rational expressions. Okay, so let's grab a screen here. Okay, and let's do an addition problem, for example. Let's say we have x plus 5 over x minus 4 minus x plus 3 over x plus 2. Okay, and I want to add these. Okay, so crisscross applesauce will work, right? Crisscross applesauce. That's an official Gnostic term, crisscross applesauce. Okay, so I can do that. So I can do x plus 2 times x plus 5 minus crisscross, so x minus 4, x plus 3, all over x minus 4, x plus 2. Okay, and the rest is algebra, so to speak. So we can multiply the top, x squared, 5 and 2 is 7x, 5 times 2 is 10, minus, careful of the sign, x squared, minus 4 minus plus 3 is minus 1x, negative 4 times 3 is negative 12, over x squared minus, and I'm going to leave the numerator factored for now, x minus 4, because I'm curious, I'm interested to see if we get any canceling. All right, so distribute the minus, which means change all the signs. So this is going to become plus, this is going to be minus, plus, plus. So 1x squared minus x squared, the x squareds are gone. 7x plus 1x is 8x. 10 plus 12 is 22. Over x minus 4, x plus 2. Okay, and I could try to factor a little bit. Let's see, 2 factors out, and that leaves 4x plus 11. But that really doesn't help because nothing cancels. And so we can leave it like that. We can leave it like the original, or we can multiply the denominator. But that's how to do a fraction addition or fraction subtraction. Let's do a division problem as well. Okay, so let's do x squared plus 7x minus let's see, 10 over x plus 2, all divided by let's say x plus 5. No, let's make it x minus 5 over x plus 3. Okay, complex fraction, so we invert and multiply, right? X squared plus 7x minus 10 over x plus 2 times, invert the denominator, x plus 3 over x minus 5. Okay, now we do want to check, we could go ahead and multiply things across, but we want to check for reducing. So we want to factor where we can. X squared plus 7x minus 10 factors as x minus 2, x minus 5. Multiply straight across, x plus 3, x plus 2, x minus 5. So we do get some canceling. When you cancel, they don't always do this in the book, but it is important to recognize that we can't cancel 0, so x cannot equal 5. Okay? So when we cancel, we add the caveat that that is a domain restriction. Okay, and this then is x minus 2, x plus 3 over x plus 2. which could be written x squared plus x minus 6 over x plus 2. Or you could leave it factored, depending on the situation or the scenario. All right, so hopefully that makes sense. Now, there is a little bit of discussion in the lesson about closure, and that is that the set of rational functions, and anytime you add, subtract, multiply, or divide rational functions, you get another rational function. Okay, and that's, I'm going to leave you to explore that with the lesson. But a rational function, two rational functions added, subtracted, multiplied, or divided produce another rational function, and that's the idea of closure. All right.